All right, we're going to talk about right triangle trig today. So there's 3 trig functions that we're going to go over today. The first one is called the sine. Most of the time, though, when you see it abbreviated, it doesn't have the E on the end, right? Like the key on your calculator is just S-I-N. It said sine, though, not sin, even though on your calculator it's S-I-N, okay? To find the sine value on a right triangle, we would look at the angle that it describes to us. So here it says to look at angle A. It says find the sine of angle A. And from angle A, the rule for sine is the opposite side over the hypotenuse. So looking at angle A, the opposite side would be the side that doesn't touch angle A. And then the hypotenuse is always the side opposite the right angle. The cosine value is the adjacent side over the hypotenuse. So again, it tells us which angle to look at. We're looking at angle A. The adjacent side is the side that touches the angle that's not the hypotenuse. It would be called your adjacent side. And then adjacent over hypotenuse, the hypotenuse again is the side that's opposite the right angle. And then the third rule we're going to go over today is the tangent of the angle. And the tangent is the opposite side over the adjacent side. So opposite is the side that doesn't touch it. Adjacent does touch it, but it's not opposite the right angle. So we're going to practice first labeling our triangles, just so that we get a little bit of practice on that, and then we'll do some of our trig functions. So looking at this triangle right here, it says to label the opposite, adjacent, and hypotenuse on this triangle. And it asks us to do it from angle theta. So here's the angle theta right here. It's the Greek alphabet letter. We call it theta. So I always like to label the opposite side first. The opposite side is the side that does not touch the angle. So this side over here that doesn't touch the angle is the opposite side. Then I like to label the hypotenuse because I think it's the next easiest one to see. The hypotenuse is the one that's opposite the right angle. It's the longest side of the triangle, so I label it. Then I'm left with my adjacent side. So it seems to me that my students have the hardest time finding the adjacent side. So I like to save it for last because then there's no question which one it is. So again, the opposite side is the side that does not make up the angle. Do you see how this angle is made up by 2 of the 3 sides? So the opposite side is the one that doesn't make up the angle. The hypotenuse is always opposite the right angle, and then that last side is going to be the adjacent side. So same thing on this triangle. We're looking from this angle right here again. I'm going to list my opposite side first just because I think it's easiest to do it that way. So the opposite side is the side that does not make up the angle. So do you see how the angle was made by these 2 sides? Then I'm going to list my hypotenuse. My hypotenuse is opposite the right angle always, so this side's my hypotenuse. So what does it leave this side to be? The adjacent. Okay, are there questions on how I'm labeling that triangle? Now, if I were to look at this angle instead, do you see that the opposite would be different? So it depends on which angle you're looking at. That's an important thing to remember. So take a look at this problem right here. What angle does it tell me to look at? The theta angle, right? It says look at theta and find me the cosine. Now, if you remember from up above, we told you what the cosine was. So go up above and find the cosine rule. The cosine rule is the adjacent over the hypotenuse. So I'm just going to write that down so you don't forget it. It's the adjacent over the hypotenuse. So looking at the angle we're going to call theta, I need the adjacent side and the hypotenuse. So I'm just going to label everything because it makes it easier. This side clear over here is the opposite. This side over here is the hypotenuse, which leaves the last one as the adjacent. So I need the adjacent side over the hypotenuse. What's the measure of the adjacent side? 4. And what's the measure of the hypotenuse? 5. So guess what the cosine of theta is? It's 4 over 5. Questions on how I got that? All right, next problem then. Ask me to find the tangent of B. So what angle does it ask me to look at? Angle B. So I'm going to go and label my triangle from this angle right here. So clear over here, the one that doesn't make up that angle is going to be my opposite. The one that's opposite the right triangle is going to be my hypotenuse. And that leaves the last one to be called the adjacent. So then go up and find me the tangent rule. So look up above and tell me what the tangent rule says. Yeah. So we're going to find the opposite side and put it over the adjacent side from angle B. So looking at angle B, what's the opposite side? 29. And what's the adjacent side? 44. Questions on how I did that? 29 is a prime number, so I know this doesn't reduce, but I would check to see if it would reduce if it could. Questions on how I did that? Are you starting to follow me? It's not too bad, right? Okay. Again, looking at angle theta, because it tells me I'm looking at angle theta. I need my sine value. And my sine formula says it's the opposite over the hypotenuse from angle theta. So, from here, the opposite would be t, and the hypotenuse would be 13. And then this side would be the adjacent. So, the sine of theta. Now, interestingly enough, we have a variable here. I'm going to show you how to solve for that in a minute, but we're not going to solve this time. The opposite would be t, and the hypotenuse will be 13. So that's good enough on that example right there. These next three examples, we're going to show you how to solve for the missing side. It's going to make it exactly the same way we just set these other ones up, but we have to decide which trig function to use. So do you guys see how they gave you an acute angle this time? We have our right angle and we have one angle that we know. We actually know this one too because we know they add up to 180, but you see how this one's like marked and convenient for you? So from this angle, I'm going to mark my triangle. This is my opposite side. This is my hypotenuse, and that leaves this to be my adjacent. So what two values do I know? The adjacent and the hypotenuse. Can you guys find me the trig function, the rule up above that uses the adjacent and the hypotenuse? Yeah. It says the cosine of the angle equals the adjacent over the hypotenuse. So I'm going to substitute my information into this. But this time, I know the angle. What's the angle? 53. So the cosine of 53 equals the adjacent, which is 45, over the hypotenuse, which is k. So do you see how I just set up an equation to solve for the missing variable? So here's what I'm going to do now. I'm going to put a 1 underneath this so that I can cross multiply. So I'm going to multiply this direction, and then I'm going to equal it to this direction. So on your calculator, you have a cosine key. You need a calculator today, not a phone. So cosine right here on your calculator. One thing you do need to do though is because my Math 3 kids have been using the calculators, you need to hit mode and make sure that you're on degree. Because my Math 3 kids have been going from degree to radians, and so they keep changing it, and you just need to double check to make sure that it's in degree mode. Once you know it's in degree mode, you can just punch that in. You're going to hit your cosine key, which is right here. And what are we finding the cosine of? 53. So I'm putting 53 in, and I'm just going to hit enter. So 0.602 if we round, right? So I'm going to go this direction and say 0.602, and then it would be times by k. And what do I get the opposite direction? 45. How do I solve for K? Divide by 0.602, good. $74.75. Okay, so what I just found there was my K value, and my K value is the length of my hypotenuse. Questions on how I did that? All right, next one. From this angle, help me label my triangle. What's this side going to be called? The opposite. What's this side going to be called? Now I can actually look, this is my adjacent if I want to label it, right? But I have the opposite I'm looking for, and I know the hypotenuse. Which trig function is opposite and hypotenuse? The sine. So the rule says the sine of the angle equals the opposite over the hypotenuse. And I'm going to substitute the information that I have in the place of my formula. So I'm going to do the sine of how much? 53 equals the opposite, which is x, over the hypotenuse, which is 15. I'm going to put a 1 underneath that, and I'm going to cross multiply. This time, do you see how it gets to be multiplied by a 15 also? So when you do that on your calculator, you're going to hit your sine key. You're going to do 53, close your parentheses, and then times it by 15, and it will give you that answer. So your sine of 53 times 15. So 11 point, yeah, can we round that to 12? Is that okay with everybody? And then this direction I get 1 times x, which is just going to be x. So what I found here was that this side over here measures 12. All right, do you think you have it? No? Let's try one more then. Label your triangle from the angle that they give you. Which side would this be called? The opposite. This one would be the hypotenuse. So what other side did they give me? Adjacent. So I have the opposite I'm looking for, and they gave me the adjacent. Which trig function uses opposite and adjacent? Tangent. So I know it's going to be the tangent of the angle equals the opposite over the adjacent. And I substitute my information into that. So the tangent of 67 equals the opposite, which is x, over the adjacent, which is 14. I put a 1 underneath that, and I cross multiply. You have a tangent key on your calculator. So you're going to hit tangent of 67, close your parentheses, and times it by 14. So it looks like that. Yeah, so if we round, these ones are kind of funny with our rounding, right? We got 32.98, which you guys are right. We could probably round that to 33. So our x value, or the length of the opposite side, is 33.